Welcome to The Jump. I'm Rich Bowers, and today with me I have data engineering and AI experts Chistina Torres and Charles Dunn. Thank you both for being here today as we talk about model collapse. To really get into this topic and get a great understanding, we probably have to start with how models are trained. Chistina, can you take us through that process and the steps that models follow in order to produce the data and information they have been?
Oh, absolutely. When models are going to be trained for generative AI, let's look at large language models just to keep things a little bit more specific. They're going to go through a series of training that's just broken up into a more iterative fashion because, when you're learning anything, it's easier to break it down into several steps. Before any of that training can occur, the first step that a developer is going to have to do is going to be collecting the data that's actually going to be used for the training. Data collection, organization, cleaning is going to be one of the most important steps when it comes to getting these models trained. There's varying different techniques that you can use in order to organize the data in a way where it is representative of the population or even representative of a specific message that you want to convey to people and have the model adopt as well. Point being, organizing the data and collecting it is going to be important, and that's done through several routes. If we look at some of the earlier models, for example, like ChatGPT or Gemini, they were trained prior to 2023, and a lot of their data was actually scraped from various sources across the internet. So if it was on the internet, it was essentially fair game. So you'll see content from Wikipedia, Reddit, YouTube, really any source that's out there. If you made a blog post 10 years ago, even that was potentially fair game to be included in these data sets. The data is large, varying, and it's very important that you get good quality data. So that's going to be where a lot of the time goes into for data collection. Once you have it, though, you can go through those series of training steps in that iterative fashion in order to get the model to produce better and better outputs.
Okay, that's a great breakdown. I have a couple follow-up questions for you. When you're saying that anything on the internet was in essence fair game, that includes private information, or are they only pulling from public? And maybe I should say, are they saying that they're only pulling from public information?
So what these companies are saying is all of the data was publicly available data that is available on the internet. But I do have to put in that caveat note that there have been some very obvious tests and accusations that are backed by some pretty obvious evidence that that is not the case, and that a lot of the data that was used, or we can say a segment of the data that was used, was collected from non-public sources.
Okay. And unfortunately, that's not too surprising, right? So they're collecting all this data and they're putting in these models to be trained. And also this includes books and anything else they can upload, right? So it wasn't just necessarily scraping the internet, but also it could be fed information or fed resources, correct?
Yes, I should have mentioned that obviously in the
That's good.
sourcing process. You don't want to obviously just get your data from the internet. You do want to use other sources so that way the model can understand the different forms of media in which content can be outputted. So, like, it's not going to be just internet content. You're going to have books, you're going to have best practices. Depending on the type of model that you're training, it would be other sources as well. Like, you may take transcript data, which is like when you're having a voice conversation, having someone write down what the words are actually being said and using that to train the model, for example. So It's going to come from various sources.
So picture this then. All that data from all these resources are going into this model to be trained. That's so much information. How could that be fully vetted? Now, there's some reinforcement trainings and practices and making sure that things are as legitimate as possible. But even in a perfect utopian filter, things are going to come on by that are not accurate. thus hallucinations and some other things. Before we go on to the definition of model collapse, Chistina, when a large language model is producing a result to a query or whatever you're asking, how is that provided to you? Is it predictive? Is that how it goes in terms of its response?
Yes. So when a model is making an output, producing a response to your prompt, how I like to think of it is it's essentially guessing each word as it goes along, but it's making very, very educated guesses because that training process that we talked about before,
Mm-hmm.
each step in the training process is made so that way the model can understand how to make better and stronger connections between words, ideas in the human language in order to output results that is going to match up to exactly what we want. So it's not actually thinking of the answer, much like a human would, where if you ask them a question, they think of the answer and then put it into words.
Mm-hmm.
Instead, they're taking the answer and looking at it just in a linguistical sense and matching up what would be the most matching set of words, or what would be the best set of words in which this would match to this request the best linguistically.
So picture this. If I was going to say four score and all of us would say 7 years ago, right? It's
Exactly.
kind of how the model is working, not knowing where that is specifically from. Okay, that's important to keep in mind as we go through the rest of our discussion here. So, with that being said, we understand now how models are trained. We understand how the outputs come to us as the users. Charles, I want to go to you because you're the one who actually brought up model collapse in a former episode of ours. Can you explain what model collapse is, please?
The phenomenon, let's call it that, the phenomenon of model collapse is when successive generations of a model produce worse outputs the more data they're trained on, paradoxically. So, as a model exists, it's performing, it's trained on more data, the quality of later generations of those outputs is lower than the quality of earlier generations. So this phenomenon has been observed in several models. I think it was first really noticed in image generation models and the diffusion models, where the quality of images goes down as it's trained on more data. And the origin of this phenomenon, as are so many things in the AI field, it is somehow incredibly complicated and comically simple. So if one of the sources of this, there could be many sources of error in this case. It's especially pronounced when a model is trained on its own outputs. So when a model is trained on what it outputted, well, think about how Chistina described it. The model is guessing, taking a very educated guess on what the next word in a sentence is, what the next phase of a diffusion generation is going to be. And if that model has certain quirks, if that model has certain outputs that are more likely than other outputs, as its source data, as what it's trained on, becomes what it already thinks is correct, it's going to get these reinforcement mechanisms of certain low-quality responses. So, as it's trained on more sources, more things that already have what it already expected to output, the original source of truth is going to get lost in that noise. As more source data is what the model expects to be put out, it's going to believe that to be the correct output even more as successive generations of it are trained.
Okay, so let me try to wrap this around through an analogy. So let's say that I'm reading a science book, And as much as I would love to be a scientist, I am not. So I go through the science book and I'm reading all about it, and I create a summary of sorts about this book. And let's say that I put this on a blog for everybody to read. Okay, here's my summary. Maybe there's an error or two. I'm not classically trained in science. Let's just hypothetically say that blog goes viral, or maybe other people start using it. Then the model could start being trained on that blog or summary, correct? The models could be?
Models could be trained on that, yes. And if you can imagine many, many, many people writing blogs that all attempt to summarize the original, correct, verified source of information. Remember, any machine learning model is just a statistical model. It says what's more likely. And if a mostly true summary is the majority of data, the model is going to see that as the most likely output, even though the original is the actual source of truth that has nuances that summaries might leave out.
My first thought was quantity plays a part in this then, right?
Yes.
So you can see the danger of that as the quantity expands of potentially incorrect information. The models will read that as real and then start producing more results with that.
Yes.
And then guess what? They're now trained on the inaccurate results because it's just so much and it becomes more and more. And one of the difficult things is that the primary source gets buried.
Yes.
Is there, this may be a completely unfair question to ask you, but as it gets buried with these summaries or maybe even inaccuracy details, is there a chance that it disappears off the face of known availability to reach?
That is an interesting question. I think the most correct answer is no. It's always going to be a part of the training data. But the practical answer is going to be more complicated because if there's so much noise, it's statistically, it's going to get lost. The original data is just going to get lost because because the model doesn't know what's true. The model doesn't know what's accurate. The model can't verify anything. The model can only say the majority of responses have looked like this. And even worse, if the model is trained on its own outputs, if the model is trained on things that it itself created, then I'm loath to use this description. You're reinforcing bad behavior.
Yeah, it would be like me learning science through my own summary instead of professionals, right?
There you go.
So, okay, that's a lot to digest, but you could see the challenge with model collapse and what it is. These models are producing something called synthetic data. This is a term that's important to know. And so I want to pass it over to Chistina. Chistina, what is synthetic data? How is it relatable here? And maybe what are some concerns with it?
So synthetic data is, another word for it is going to be fake data. To put it into perspective, let's think of it in terms of another fake substance or synthetic substance, artificial sugar or synthetic sugar. It is a product that is made to mimic its real life counterpart. And by mimicking that real life counterpart, but not actually being that real life thing, we can manipulate it and remove certain qualities we don't want or certain qualities we just would like to avoid from it. When we look at data specifically, when we're working with synthetic data, it tends to be fake data that we're working with for testing purposes, demonstration purposes, or even just to learn a new technology. But it's data that really shouldn't have any implication or meaning into the project. It is just there so that way we can test out other aspects or learn other aspects of the project. Something we have to keep in mind with models, though, is the data that they are outputting is a form of synthetic data. It is data where we cannot confirm its accuracy, and it is oftentimes used in order to generate these data sets. Because synthetic data, if I'm making it, I'm using a algorithm to make it. Exactly the same thing that ChatGPT, large language models like that are using underneath the hood. They're using just algorithms in order to output best matches or data. So synthetic data is closely tied together with AI outputs.
Okay, thank you. So when we're hearing synthetic data, you use the term fake, but it's not necessarily a bad thing per se. It could be more so a substitute when there isn't actual, I guess, information on that topic.
Yes, it's used as a substitute. Usually synthetic data, though, it is replaced with actual data when you move that product that you're using the synthetic data in. You replace it with actual data when it gets to the means of actually doing the work. When you're using synthetic data, you are going to get basically synthetic outputs. You cannot guarantee the outputs are going to be factual or even accurate when your baseline isn't factual or accurate.
Maybe that's popular for like if I'm having a theory, right, that this could happen, and I would use synthetic data to fill that gap.
In terms of generative AI specifically, I think is the main question, because if you're using it in like a general computer science or data engineering field, then synthetic data is more often used than regular data because it's easily accessible. It avoids the use of personal information being used or data being illegally gathered or copyright data being used when it's not supposed to be used. So in those aspects, synthetic data is actually preferred over real data. But when you're looking at generative AI with synthetic data, the problem arises when that's in the training data set, because how the training process works is it focuses in on certain aspects. And we see this with like bias training, for example, where it will blow up things that we did not identify in the data sets, problems we didn't identify in the data set. And when you mix synthetic data into that training data, you give the model a chance to focus in on the inaccuracies of that data and blow it up and make it into a big point in its personality or its outputs. So it's really hit or miss if you do want to integrate it into generative AI, because it has to be done in a way that is tasteful and avoids those negative pieces that would be blown up.
So when we're talking about model collapse over time, I mean, it's in essence primarily producing information that just has a quantity aspect. Does that mean that we'll see more synthetic data to fill gaps for it to try to be more accurate?
I believe that is a course of action that can come, but it's going to be heavily monitored synthetic data in the sense of like, it's going to be, if you have an AI model, for example, produce this synthetic data, you're absolutely then going to have a human counterpart step in and check the quality of that work.
I've never dove into synthetic data that deeply to see all the different angles, and I appreciate that you're able to highlight them. You know, to me, Charles, here, this feels like entropy. It's a word that we hear a lot in like the laws of thermodynamics. And is that something that could be relatable in this thought process? When I'm thinking of model collapse, I really am thinking of the deterioration towards disorder.
That's a good way to think about it. Now, remember, entropy is originally a term from the physical sciences. Just remember the three laws of thermodynamics. You can't win, you can't break even, and you have to play the game. Basically, the idea is that you can't extract all energy from a system. A system will always have waste. A system will always have waste heat, and there's no process in the universe that is immune to this. So, if we think about entropy in an information system, that has a slightly different definition. That is going to be the randomness of a given variable and level of uncertainty about a given variable in a system. And if we look at each piece of information, within a language model's training set, that uncertainty is always going to increase because we don't know, because as we have these successive generations of model training, that information is going to be lost in the massive statistical generator that is a language model, that is a machine learning model. So it's entropy. It's, once again, it's not one-to-one. It's not an exact definition, but it is a good mental model that you can use to understand this phenomenon. But that analogy will degrade over time as you use it as a substitute for a core understanding of what's going on here.
Man, if we didn't have two more questions, that would have been a perfect way to end this. The way you just pulled it all together. The reason why I was looking at this is because you can never go backwards with disorder,
Yes.
which is second law over there.
Mm-hmm.
And so my thought process here through our discussion was that model collapse is happening because of all this data being sent out. And obviously, we all know the stats, more and more data year over year than whatever the 100 years before combined or whatever it is. And I'm assuming with these models, especially these large language models, even more is being produced. And so that's just going to create more and more disorder. And I'm glad you're able to kind of break down, how it's related and maybe some differences there. Charles, one question before I jump to Chistina on maybe some impacts and some solutions here. When we're looking at this information going into these models, is it different for AI agents or small language models? Is it different because there's higher observance or more specialty with that?
You know what? Yeah, you could say that. Like, the more focused models are going to have certainly more oversight in what they're trained on. There's going to be a more narrow data set that is going to be more easily monitored, more easily understood, more easily filtered. That kind of human oversight going into a model is going to alleviate this problem, but again, that increases the amount of overhead that's required to ensure a model's correct functioning. So there's maintaining a model is going to take effort.
And expense as well,
and
right?
Expense, yes.
Yeah. So thanks, Charles. Chistina, what are some ways to alleviate model collapse? How can we get ahead of this?
The most straightforward way that I just want to put out there is going to be if these companies that already have data sets that don't contain high quantities of corrupted data or generated data, having them put these data sets out there for public use. So publicly available data sets that are already reviewed and prepared. But let's not focus on that because that is just theorizing and dreaming at the moment. What we are focusing on and asking about is what can we do now, given what we have available. So that is going to be basically end all be all monitoring the quality. And we can do that in many different ways. We can make sure that initially when we're gathering the data, actually checking the type of data that we're putting in, doing our best to put checks in place to make sure that we are minimizing the amount of synthetic data that we're putting in. And if we know we are putting in synthetic data, whether that be actual synthetic data that we're manually making or synthetic data generated by an AI model, making sure we have some human oversight on that to check out the quality of that is going in. The second thing that we can do is going to be, this is going to be a slow iterative process and involve interference from large companies, is going to be having that labeling system in place for generated content that is being put out new, and then also retroactively fitting that to generated content that's already available on the web. Because when you have properly labeled data, it's going to make the training process much easier for the model itself to understand, like, hey, this was a synthetic piece of data, this is a real life piece of data, and understanding that it should be giving more weight to those real life counterparts. One more point I do want to mention is setting up tests. There's going to have to be a lot of testing in place in order to check the quality of the model's outputs. When you have a test that's in place to see what's the model's outputs after each training stage, you want to look out for any dips in quality, and that's going to indicate that something is wrong with the training data and you have to go back to fix that. So really, it's going to be a lot of what's quality assurance tasking is for general data management. It's going to heavily apply to generative AI as well, because without that human interference, we're just going to slowly lead ourselves down to the model collapse route.
So back to the human support, the bulwark of us getting flooded with model collapse inaccuracies.
Exactly.
I like those solutions, and it'd be interesting if companies pick that up. But I think that makes sense. Charles, to wrap us up here, what type of impact are we seeing? Let's fast forward a couple years down the line, if those solutions that Chistina provided are not implemented.
We have seen what happens. We've seen models, the quality of models degrade over time. There have been many studies published on this about how models trained on their own outputs get worse. We've seen models trained on bad data produce bad results. You know, the old saying, garbage in, garbage out. There's no amount of machine learning you can do to bad data to turn it into good data.
Mm-hmm.
But at the same time, this problem is very solvable. It's a real problem. It's a complicated problem, but the solution is known. And most of the companies that are going to be maintaining these very large, very prominent language models know this. They know what they have to do. They know how to solve the problem of degrading model quality. But I do want to talk about how within this discussion, there's a more insidious problem. There's so much generated data out there that the models are starting to be trained on that. We are rapidly approaching the point where there's simply no more human-generated data to train the models on. They have been trained on the entire internet. They have been trained on entire libraries. We're running out of massive sources of correct, verified data, for as correct and verified as Reddit could possibly be. But if you think about it, this means that so much of the internet now is generated data. So much of the internet is AI-generated, unverified, low information density data that is just out there, and we don't have a team of quality assurance engineers to make sure that the data that's coming into our brains is verified, to filter out the bad data, to filter out the hallucinations. We don't have that. The internet is slowly just becoming inundated with low quality, statistically average data with no outliers, where the outliers represent peaks of valuable information. That's all being smoothed over by the training algorithms of these language models. Model collapse is a solvable problem. The internet slop machine is a serious problem that needs to be addressed.
Yeah, I mean, and that's such a challenge. You go image searching, you go looking anything up on Google right now, it's AI slop.
Yeah.
Overall, and it seems like it's going to get worse unless those steps are put into place. So, Charles and Chistina, informative as always, and I'm looking forward to talking more about this topic and hopefully on how the steps are being taken to remedy it. So, for The Jump, I'm Rich Bowers. Take care, everybody. Bye-bye.